We're going to work on series resistors. Series means hooked up end to end, so it has to run through one and then the other. So if you look at our example here, we have power coming in to row 1 here, goes through the switch when we turn it on, runs in the same row as the resistor. And this is not the example that you're going to build, it's just a sample, not to give the math away. But we have a brown, black, red, gold. It's going to run through this 1K resistor, comes into the same row as the other resistor, so then current can flow through that row and then go through the next resistor. In this example, it's a 3.3 for the second resistor. Comes on down to row 30, I believe here. Runs through the LED, make sure your short wire is on the same row as the black wire, and then runs back on the battery. So if we were to turn this on then, it's going to turn the bulb on, but the current is forced to flow through both resistors in order. So the way the math works here, if we come up here, is we have series resistors, which means they're hooked end to end. Their values add together, and so we have a formula of R1 plus R2. So that's the formula, R1 meaning resistor 1 plus resistor 2, and that's exactly what we have here, resistor 1 plus resistor 2. And you just, simple math problem, 1K plus 3.3K is 4.3K ohms, so this is the omega symbol for ohms, and that's your total resistance. So if you were to read the total resistance here, you could set your multimeter up to 20K, and you could touch it there with one probe and touch it there with another probe, and it should be very close to 4.3K. If we look at our schematic, this is what we hooked up. We have a 9-volt battery which runs to a switch, then to a 1K resistor, then through a 3K. So you can tell these are in series because it has to go through one, then has to go through the other, then your LED, and then back to your battery. Resistance by definition is an opposition to flow because there's a loss of energy. Don't directly hook up your battery to your LED. It'll blow the LED and there'll be a lot of current. This is an opposition to flow, so there's a loss of energy from the battery to the LED. And that's series resistors. Parallel resistors are a different way to hook up resistors. These are going to be hooked up side by side, not end to end like series. The total resistance, when you hook them up in parallel, the value actually will go down. We'll come back to the math here in a little bit. If you look over at the schematic, basically the current is going to flow out of the battery, go through a switch. Now I've eliminated the switch in this so you can see more clearly, but you could definitely have a switch in this. And then it has two ways it can go. It can go through the 1K, and at the same time it can go through the 3.3K. And then it's going to come back together and go through the LED and return back to the battery. Now, what's a little confusing here is the value goes down, it doesn't go up, like on series resistors to 4.3. It's going to be less than 1K because it's actually more opportunity for it to flow through. So more current can flow through two resistors side by side than one resistor in the circuit. So if we look at how it's hooked up on our breadboard, power is going to flow into one row, and the important thing here for this to be parallel is that they start in the same row and they end in the same row. They may look like they're side by side, but it's definitely a key here that it starts in the same row, ends in the same row. You can see I eliminated the switch so my light's always on, which is one of your questions on the SchoolNet test is, do you have to have a switch for the circuit to work? No, it just controls the circuit on and off. So this is parallel. Now let's look at the math, what's going to happen with the total value. We have the same resistors as the last example, a 1K and a 3.3K. In the last example in series, the total resistance was 4.3. Now if we come up here and figure out our math, our formula is R1 times R2 over R1 plus R2. So basically resistor 1 times resistor 2 over resistor 1 plus resistor 2. So if we plug the numbers in here, 1 times 3.3 is 3.3. 1 plus 3.3 is 4.3, and then you're going to go ahead and divide, and you're going to get 0.76k ohms. Okay, so you can see that 0.76 is less than 1, so there's actually less resistance by hooking them up parallel to each other. Now just for your information, this is not the answer you need for experiment 4. Those are different resistors, so you're going to have a different math problem that you have to show the teacher.